Alrighty there. Hello, Callan Middle School 8th graders, 2022. We just took a test. I believe it was, yesterday? Some of us did okay. Some of us did really well. Some of us not so much. First of all, before we go over some of those most commonly missed questions, I would like to first talk about the periodic table. Your teachers and I have all agreed that if you were to brain dump before you took the test and you did a thorough job and it was correct, that you could have earned up to 5 points. Some of you did a really great job at that. Some of you tried, but you got things wrong, and then others didn't even attempt. I promise you, if you brain dump and you get in the habit of learning this material well enough to brain dump on the periodic table or notebook paper, it will help you not only in the process of studying, but it will be a thing that you could fall back on when you are taking the test. So again, please take our advice when we say brain dump strategy, and it is proven to work. Okay, so on the back side, we're not really ready for the formulas yet, but on the back side, I had my classes brain dump what they should know about the periodic table, or I should say the atom structure at this point. And one of the first things we've learned was ape man. That's A equals P, which tells us the identity. IDENTITY. Identity is the name of the atom. The identity is always going to be tied to the protons or the atomic number. Those numbers never change. So that is constant. Now, if I don't give you a model with the electrons present, then you can assume that the electrons are equal to the proton. Again, this is not in every atom. This is only in neutral atoms. Okay, so neutral atoms only will your protons be the same as your electrons. Okay, we learned just before the test that electrons, more specifically the valence electrons, determine an atom's reactivity. What is an atom's reactivity? The reactivity has to do with an atom's likelihood that it will chemically bind with another atom to form a new substance with new chemical properties. This happens through the process of a chemical reaction, which we will get into in the next few units. But right now, just knowing the valence electrons determine reactivity. Reactivity is a chemical property. Okay, reactivity, chemical property. That was on the test. A lot of you struggled with that one. Chemical property. Everything I'm writing right here are the things that you should be considering to write on your test on the next time you attempt it, your retest. Have a brain dump, study in advance, practice the brain dump, and on the day you come in for the retest, you should be able to recreate this on a scratch sheet of paper without using your notes. Okay? So the first part of 8-man is just how we identify protons and electrons if we're looking at a model. If I don't have a model, we can still figure out how to draw one or how to interpret it if we have a periodic table where you can find the atomic number. Okay? Man, the second part of this is M minus A equals N. That's your mass number. That's the number that you can either get. Sorry, I got a doctor's appointment. Okay, we're back. I'm not sure where I was at, but the second part of the equation, or the second part of our phrase, is man. That's mass number minus atomic number equals the number of neutrons. Now, if I were to give you a model, obviously you could figure out the neutrons if they're labeled. For instance, I give you a model that has a couple, circles in it. Maybe the circles represent the neutrons because they're neutral charge, and then you have some protons which are positive. Obviously, you could just count the neutrons, and there you have it. But sometimes those are not given to you. Again, I'm going to finish this model. These are electrons on the energy ring. Okay, you don't have to brain dump a model of an atom, but this is a Bohr model. Again, we know our protons and neutrons are in the center, and our electrons are on those orbitals that are constantly moving around the nucleus. Okay, now in the event that I give you a mass, remember, sometimes the mass of the atom I give you is greater than the mass, the average mass that you can find on the periodic table. Each one of these is an average mass. If you were to take every atom of nickel, add up its weight, again, those are my air quotes, it's not really weight, it's mass, but you add them all up, then divide by the number of atoms that I was calculating the average for, that would give you this decimal number. Okay, so when we are trying to determine the mass of the average, you would round that to a whole number, so 58.6 would round to 59. But I don't always do that. Sometimes I give you a model, and that model might not be the same mass as what it would be on the periodic table for the same element. Clearly, this is a different atom than the nickel that I just pointed to. But if you take the mass, and again, since I'm looking at 3 protons, we also learned that the identity, again, comes from your atomic number, which is equal to protons. If I have 3 protons, we're going to look for the identity, atomic number 3. The identity is lithium. If I wanted to find neutrons, you're going to look at the mass down here at the bottom. If this is the mass or this top number is a mass, you can always go to this little key in the center here. The bottom number is the mass, the top number is the atomic number. So you do mass minus atomic number. Again, the mass for lithium, again, let me show you where that's at right here. 6.9 is going to round to 7. 7 AMU minus the 3, which was the number of protons or the atomic number, will give me 4. So there is technically 4 neutrons in the average. Now notice in my model I only have 3 neutrons. So it's really important that if I give you a model to use my model, because if I said what is the mass of this atom, the mass is not going to be the same as the mass of the average. The mass of the average atom was 7 AMU. The mass of this atom is 6 AMU, atomic mass units. Okay, so just little things that you need to consider. Again, I drew some extra things on here to give you some examples of how this works and when to use it, but you definitely need to have 8-man. Okay, you don't have to draw the models. Okay, another thing that I wanted you guys to add to your brain dump was a subatomic particle summary chart. Basically 4 columns, 4 rows. This top one doesn't do anything. I like to write it in the order PEN because it spells the word pen. We have charge. Each particle has its own charge or no charge. Each one has its mass or no mass. And then, of course, location. The charge of a proton is positive. Charge of an electron is negative. Charge of a neutron is neutral. We use 0 to represent the symbol. Again, it means neutral. Protons and neutrons are found in the center. They make up the mass. So when I say what is the mass of 1 proton, it is equal to 1 atomic mass unit. Neutrons, same thing, 1 atomic mass unit. The electrons are so small, we say they are 0. 0 AMU. And then, of course, location. We know that the protons and neutrons are found in the nucleus. I'm going to put nuke because, well, you can see I don't have space. Nuke. Electrons are found in the cloud. The cloud is the region outside of the nucleus. Again, I probably should have used a different color here for the nucleus. But everything outside the nucleus is considered the electron cloud, and that's where your electrons will be found. So they're very useful, okay? There was, I believe, 2 more things I wanted you guys to brain dump. In addition to n minus a equals n, if I were to give you a model, if I said what is the mass, what 2 particles are you adding together? Mass is protons plus neutrons. Okay, protons plus neutrons. So that was a formula that's really useful. Brain dump that so you can reference it if you need to. And then we also talked about charge. What's the charge of the atom? Charge of the atom is P minus E equals C. C meaning charge. And again, I'm going to say charge of atom so I know specifically I'm talking about the entire atom. So for my particular atom up here, I have 3 plus signs, which is protons. I have 3 electrons, which is negative. And neutrons don't count because they have no charge. So if I wanted to find the charge of this atom, it would be 3. Why did I do that? Okay, we're going to rewrite the equation here. I always say start with this anyways. 3 protons minus 3 electrons equals 0. Again, an atom that has a 0 charge, we describe it as neutral. Okay. Another type of question we might ask is, what is the charge of the atom's nucleus? Again, the nucleus is in the center. If I say, what's the charge of the nucleus? I'm counting just the protons. The neutrons don't have a charge, therefore they do not count in terms of charge. The charge of the nucleus would be positive. Positive 3. Nucleus charge, first of all, is always positive. Oh goodness, always positive. And it's positive the number of protons. Very important. So this particular atom is going to be plus 3. Okay? So it's really important that you guys know that. So these are kind of the minimal things that I would recommend that you put on the brain dump. If you did all this, you probably got your 5 bonus points. If you made any mistakes, we might have given you a little less. So with that being said, let's look at our actual test. There were some questions that I wanted to focus on that were well below average in terms of the number of students who got them wrong. This question says, an atom of vanadium has an atomic number of 23 and a mass number of 52. How many protons does it have? So if I give you atomic number, again, using your brain dump, super good information here, I know that my atomic number is always equal to my protons. Okay? The question says, how many protons? Again, it's that simple. It's how can you use your brain dump to help you? Again, the more you practice it, the easier it gets. If there's 23 atomic number, protons is also 23. That is your answer. Mass number 52, we call that distractor factor. It's a number irrelevant to the question I'm asking. So cross out information that's not relevant, underline or circle information that is. Okay? Another question that that a lot of students struggled with. Which of the following determines the identity of an atom? Again, identity, vocab word, that was associated, again, if we go to our brain dump, the protons or the atomic number tells us identity. Okay? We talked about how different atoms of the same type of element could vary in weight or could vary in mass. Why? It's because the number of neutrons can change. So we can't rely on the number of neutrons to give us the identity or the name of an atom. The same goes for the electrons. Electrons, sometimes we have atoms that are charged. They might have more or less electrons than protons. Cannot rely on that to tell us identity. Mass number. Even though mass is protons plus neutrons, is the periodic table always going to give you the same mass as an individual model that I'm giving you on a worksheet? The answer is no, because what we see on the periodic table is an average. So the only reliable thing that will never, ever, 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 ever change would be your protons. That will determine the identity. Then you go to the periodic table, you get your name of your atom based on that atomic number. Again, as you look through it, it actually becomes really easy when you start to realize what silly mistakes we've made. Okay? A neutral atom of nickel has an atomic number of 28 and a mass number of 57. How many electrons are in this atom of nickel? So going back to our notes, I always think it's a good idea either go to your notes or rewrite what you know you need to rewrite. If I didn't give you any information about the number of electrons, then we assume that it is neutral. Protons equal electrons. I know that protons are the same as the atomic number. Atomic number is 28. Protons must be 28. Therefore, electrons must be 28. Again, this 57 is a distraction. Now, why would we use the number 57? Well, if I ask, what is the mass of this atom, then you could do m minus a equals n. But again, it's what is the question? How many electrons? Again, always circle, underline specific information that's going to help you answer the question you are looking at. Let's see. I did pretty well on all of these. Here's another one I saw a lot of people miss. How many valence electrons does carbon have? Valence electrons. We talked about this. Unfortunately, we didn't get a lot of time to spend on it, and we did do some curving of the grade to adjust for people who miss questions, especially like this one. Valence electrons would be the number of electrons on the outermost ring. So if we're looking back at my little example here, the valence electron would be this. Okay, your valence electrons in this case, if we're looking at that model, is just 1. There was a rule that we have taught you called the octet rule. O-C-T-E-T rule. This rule is specifically for the valence shell, or the outermost energy level containing electrons. The octet rule states in the first 3 rings, if the outermost energy level, if it's the first ring and it only has electrons on the first ring, if it has 2, it will be stable. If it has 2 rings, the second ring, well, the first ring will always be filled first. The second ring will have to have 8 to be stable. And if it has 3 rings, the first 2 rings will be full, and the third ring will have 8 to be stable. I don't teach you beyond this. There are bigger, more complex structures, but the rule is 2-8-8. The outermost ring should have 8 to be stable. So when I say how many valence electrons does carbon have, first of all, carbon. Where are we going to figure out information about carbon? We're going to have to go to the periodic table. You might not have it memorized yet, but I guarantee we're going to go over this so many times, you're going to know exactly where to find it. Carbon is capital C. I want to know valence electrons. Again, if we go back to our brain dump that we practiced, and we studied, and we memorized, and we can say, wait, this must be a neutral atom, so protons should be equal to electrons. The atomic number is equal to the protons, which is equal to the electrons. Now, maybe the notes are a little confusing. The electrons are not equal to the valence electrons. The valence electrons are specifically the outer ring, so I'm going to add outer ring. Outer ring only. Okay, just to make sure that we understand. Okay, again, that looks like a C. It's outer ring only. Okay, so going back to my model, I have 2 rings. If I have 2 rings, how many electrons do I need to have for it to be stable? I need to have 8, but I have 1. This would be a reactive atom. Okay, so reactivity is based on the octet rule. If the outermost level does not have 8 valence electrons, then it is reactive. And I'm getting ahead of myself here. The question is not even asking if it's reactive or not. It just wants to know how many there are. So carbon, I think it's a good idea to draw a model. I'm just going to draw the letter C. That's my nucleus. We're not worried so much about the nucleus as we are the electrons. So the nucleus, oh my, all these distractions. The nucleus is right here. And again, I like to differentiate my nucleus from my electron rings. I'm going to draw, I need 6 total. I can only put 2 on the first ring. So that means I got to draw another ring and draw 4 more. So I just answered my own question. How many valence electrons does this atom have? 1, 2, 3, 4. The answer is 4. Okay, the more we practice, the better we will become at answering these questions. Number 23 was another commonly missed question. What is the name of the atom in the model? If I'm asking for name, you should probably be telling yourself, ooh, protons, identity, right? Identity tells us the name. When I say brain dump on your test, this is what I mean. Now, I know if it's an online test, you can't do that, but guess what? You do have a periodic table and notebook paper. You can write anything you want on that. If you don't have it, ask your teacher, okay? This is your identity. So there's some information in this model that's unnecessary. For instance, I don't care about the neutrons. I honestly don't care about the electrons. Identity comes directly from the protons. I also know that protons are equal to atomic number. I've memorized that. It's on my brain dump that I can reference at any point during the test. So the identity, if it has 11, would be sodium. Okay? And I believe that is this answer right here. just have a few more to go over. This one a lot of people miss, and I'm not sure if it was a matter of not following the directions. I did say correct unit. I also have a text box here. A lot of people didn't see multiple choice, so they just skipped it all together. You don't want to get it wrong because you didn't see it and you chose not to do it. But unfortunately, I think a lot of people made that mistake. The question says, use the model below to determine the mass of this atom. Numeric value, that means I want a number with correct unit. We've been talking about if it's something we measure, you need to include the units. So I want the mass. Brain dump, you know the mass equals protons plus neutrons. You also wrote it right here on your brain dump. You reference that when you are having a moment of fog. That's why you want to go back to your brain dump. Okay, where are your protons and neutrons? Again, protons and neutrons, if you look at your summary chart here, protons are found in the nucleus, neutrons, nucleus. All I have to do is count these. 1, 2, 3, 4, 5, 6, 7. Now, if you put 7 by itself, you are wrong. I was looking specifically for 7 AMU. I did state that I wanted the correct unit included. If you skipped the question or if you left the AMU off, unfortunately, you got it wrong. Okay? So, again, read carefully. Make sure that you use your brain dump, and you will be successful. Number 26. Using the atom model below, how many valence electrons would be present? Again, this is another one of those we didn't get to spend a lot of time on, so I did curve the grade for some of you who missed this particular question. We take the model. Notice it doesn't have all the particles. It only has positive charge. We know every atom should have protons, neutrons, and electrons. There are some exceptions, but most of them are going to have some number of each of those. I'm seeing protons only. So I'm going to start with that. 1, 2, 3, 4, 5, 6, 7, 8. I have to assume this is a neutral atom because electrons are not given to me, and there's no way it doesn't have any electrons. So 8 electrons because it's neutral. Again, we know neutral means P equals E. If it's not given, again, we have it here, neutral atom only. We have to assume it. Neutrons, in this situation, to find neutrons, we know that mass minus atomic number gives me neutrons. Mass on the periodic table, if the identity is based on the atomic number 8, is 15.99. That rounds to 16. 16 minus 8. Use your calculator, show your work. The answer is 8. Now, some of you are probably saying this, we're not asking for neutrons. Why are you doing that? Well, this is a review after all. So that's how you find the pin. I still haven't answered my question. How many valence electrons does it have? Valence means the outermost shell. So in this situation, draw a Bohr model. Again, we're looking at something that has 8 protons. 8 must be the oxygen atom. Instead of writing O, I'm just going to write oxygen just because I don't want to confuse it. I don't know. That's my nucleus. I don't feel like putting the protons and neutrons, but you know it goes there in the center. We're talking about valence electrons, so it's really important that we draw the electrons. That's what's going to determine what the answer is here. Okay, so there's my nucleus. If I have 8 protons, I need 8 electrons. The rule is you can only have 2 electrons on the 2 electrons on the first ring. 1, 2. I need a total of 8, so I need 6 more. 1, 2, 3, 4, 5, 6. I jumped down to the bottom just to make it symmetrical. Okay, so how many, go back to the questions again, how many valence electrons would be present? Notice how there's so many steps, guys. It's important to constantly go back and forth, brain dump, then go back to the question. Get as much information as you can, and then make sure you're answering the question correctly. You might have other information that's not necessary, so it's important that you always go back to the question. Did I answer what the question's asking? I'm counting 6 valence electrons, and I also see 6. Valence electrons are the outermost energy level. And we have one more on this last sheet that I wanted to cover with you guys. When determining elements' chemical properties, and again, this was something we were kind of on the edge with knowing, chemical properties, the most important subatomic particle to look at is, anytime you see the word chemical properties and we're talking about atoms, you need to also think of the word reactivity. Reactivity is determined by the valence electrons. That is something that we've brain dumped, and that's something that you can reference when you get this question and you know, ooh, valence electrons, reactivity, okay? If valence electrons wasn't an option, but electrons by itself was, then that would be the next best answer. But valence electrons is the most specific, and that is the correct answer. I hope going through the brain dump and some of these most commonly missed questions helps you guys realize your mistakes. Your retest will be made based off of some of these commonly missed questions. However, we will be giving you different questions, so do not memorize what I'm telling you. I want you to understand what I'm telling you. Practice the brain dump. Make this brain dump over and over and over again until you get it perfect. Then you reference the brain dump to answer the questions. It is a strategy proven to work, but you have to practice. It's like sports. You won't get better until you practice and practice and practice. I promise you guys you're going to get better at this. Thank you.